Yep, we're going to do that right now. So on page 13, we have here multiplication, elimination notes that we're going to be completing on page 13. And this is used when one of the variables cannot be eliminated by adding or subtracting the equation. So if you remember yesterday, every system that we saw, you were able to eliminate it because maybe it looked like this. 2x plus 3y equals 10, and then maybe like 5x minus 3y equals 12. Yesterday, every single one of the problems could be eliminated because you either had opposite numbers like 3y and negative 3y, or you had the same numbers like 3y and 3y, and you could either take the two equations and add them, or take the two equations and subtract them to eliminate one of the variables. Today, we're going to be seeing situations where you cannot just take one of the equations and add the other to cancel out the variables. So we have to add one more step to the process, which is step 1. You'll have to multiply one or both equations by a number so that you can use elimination. Once you do that step, then everything else will be the same as yesterday. It's just one more additional step. And that's because looking at example 1, if we were to solve this by elimination, in order to eliminate the equations, I have to either have the same exact number of x's or y's or the opposite number of x's or y's. If I took these two equations and I added them straight down, nothing would eliminate because 1x plus 2x is 3x's, 1y plus 7y is 8y, 2 plus 9 is 11. That doesn't help me at all. In order to eliminate a variable, the variables have to be opposites or they have to be the same so that you can either add the two together or subtract them. Because that's not helpful, that means that I have to take one of the equations or both of the equations and multiply it by a number so that you can use elimination. So there's no right or wrong way to do this. You have to just choose a variable to eliminate. So again, like with substitution, when you're trying to find the easiest one to solve for, now you're trying to find the easiest variable to eliminate. So looking at the first equation, this is x plus y equals 2, and the second equation, 2x plus 7y equals 9. You can decide if you want to eliminate x or you want to eliminate y. If you want to eliminate x, then your whole goal would be to get this x here to say either 2x or negative 2x by multiplying everything by 2 or negative 2. If you wanted to eliminate y, then your whole goal would be to get this y to equal either 7y or negative 7y, so it will cancel out with that one there. It doesn't matter what you solve for or what you want to eliminate, you just have to choose one. So for this case, I'm just going to say let's eliminate x. So on the side here, I'm going to write that I'm eliminating x. In order to eliminate x, I have to take the whole problem, x plus y equals 2, and 2x plus 7y equals 9. And I need to make the first equation so that it's going to be able to eliminate with the second equation. Your goal is to either turn the x into 2x or negative 2x. If I take this whole entire thing and I multiply it by 2, then here's what it will look like. You multiply every single term by 2. 2 times x is 2x. 2 times y is 2y equals 2 times 2 is 4. What I did was I took the entire equation and I multiplied everything by 2. And now if I write the second equation underneath of it, the 2x plus 7y equals 9 equation, now I can use elimination and I will be able to eliminate the x's. In order to eliminate the x's, I will have to do what? Add them or subtract? Yes. If I subtract, then I have 2x minus 2x, and that'll go away. 2y minus 7y will be a negative 5y. And 4 minus 9 will be negative 5. Just be careful when you use subtraction. You have to take the first number and subtract the bottom number. When I have this, I can easily solve this by just dividing both sides by negative 5, and I'm going to get that the answer is y is equal to 1. Now that I have that, I can just replace that number back in for one of the equations and solve for x. Looking at the equations from the beginning, I feel like the x plus y equals 2 is easier. X plus y equals 2. I now know that y is equal to 1, so I replace a 1 in for y. Solving for x, I'm going to get x is also equal to 1. So altogether, I get my answer is 1, 1. And I did that with eliminating x. That is not the only way to solve this problem. So I'm going to show you a second way. There's actually multiple ways. There's 4 ways to solve it with elimination. But I'm going to show you a second way. I'm going to let everyone write this down just so that you have the notes. And then I want to show you what would happen if you did it a little bit differently. So look back to this very beginning up here. What I did was I took the equation, I multiplied it by 2, and then I eliminated x. I can also eliminate x by doing something else. So if I take the first equation, x plus y equals 2, to eliminate x, I could, instead of multiplying it by a positive 2, I could actually multiply everything by negative 2 so that they turn into opposites. When I multiply everything by negative 2, it's going to be quite just like the opposite of what we had originally. Now I'm going to say negative 2x minus 2y equals negative, or I need to multiply by negative 2, I'm sorry, negative 4. And then on the bottom, the second equation is 2x plus 7y equals 9. If this was the 2 equations I was going to be working with, now what would I do to eliminate the x's? Would I add or subtract them? Yes. Now that they're opposites, I would add, since negative 2x plus 2x cancels out. Negative 2y plus 7y is 5y. Negative 4 plus 9 is 5. So I'm still going to get the same exact answer when I divide both sides by 5. I'm going to get y is equal to 1, and I'll get x is equal to 1. It's just a different method. And there's even more to solve each one. I don't have to eliminate x at all. Instead of eliminating x, I could also take this equation and I could eliminate y. It does not matter. You're just trying to find the easiest solution. So if I take this system of equations and I want to eliminate the y, I'll have to take the first equation and either make it so that it says 7y or negative 7y. So what you could do with this one is take the first equation and multiply it all by 7 or negative 7. And if you do that, let's just use positive 7. It'll turn into 7x plus 7y equals 14. When I take the first one and multiply it by 7, and then I have 2x plus 7y equals 9. So if I use this method, in order to eliminate y, since the y's are exactly the same, I'd have to subtract. And then I would get 7x minus 2x is 5x. 14 minus 9 is 5. I'm going to get now that x is equal to 1, which it is. And I could use that to solve for y. So there's more than one way to solve each problem. You just have to figure out which one either makes the most sense to you, or just you can always eliminate x or you can always eliminate y. It's really up to you. So looking at number 2, we'll start with a fresh system of equations. We have negative 10x plus 3y equals 1. And 5x plus 6y equals negative 23. We can either eliminate x or we can eliminate y. It's up to you. Looking at these options, I know that I can't just add them straight down and anything will cancel because nothing's exactly the opposite. I can't either subtract them straight down because nothing's the same. So in order to solve this system, I have to take one of the equations and multiply it by a number so that it can eliminate. So your option would be to either eliminate x, and if you do eliminate x, you'll have to take this second equation and multiply it by 1. If you want to eliminate x, and you want to take this and make these two things be the same number or opposite, for this one, since this is a negative 10, in order to get this one into like a type of 10, I can multiply the equation by what number? 2. Yeah. I can take the second equation and multiply by 2. And if I take the second equation and multiply it by 2, it's going to look like this. 10x plus 12y equals negative 46. And I can write the first equation above it, negative 10x plus 3y equals 1. And now if I have these two equations, I will be able to use elimination because the negative 10x will cancel out with the positive 10x if I take the two equations and I add them. So what I can do then is add straight down. Negative 10x plus 10x cancels out. I'm going to be eliminating x then in this one. 3y plus 12y is 15y. And 1 plus negative 46 is negative 45. Once I have this, I just divide by the number in front of y, which is 15. I get y is equal to negative 3. Once you have one of the solutions, then you take that answer and replace it in for whatever equation you want. I usually like to go back to the original equations. You can use the first one or the second one. I'll use the first one, negative 10x plus 3y equals 1. I'm going to replace in a negative 3 in for y, since that's what we just found it to be. And I'm going to solve for x. 3 times negative 3 is negative 9. So this will say 10x minus 9 equals 1. Adding 9 to both sides, I get negative 10x equals 10. And then I would divide both sides by negative 10. And 10 divided by negative 10 is negative 1. So altogether I solved and I found that the answer is negative 1, negative 3. That is not the only way to solve it though. You could have eliminated y instead. If you choose to eliminate y, then you should be looking at the y numbers and thinking to yourself, okay, what would I have to do to get one of them equal to the other? So if we're looking at the green circle, what I just circled there with the y's, in order for the y's to eliminate, since I have 3 and 6, I would have to take this equation and turn it into either a 6y or a negative 6y. So that means you would either want to multiply the first equation by 2 or negative 2 so that the y's cancel out. It's really up to you what you would like to do. You're just trying to find the quickest, easiest way. And then don't forget, after you get your answers, you can always verify that those are correct by taking those numbers and replacing them into the original. Negative 10 times negative 1 plus 3 times negative 3 should be equal to 1. This is equal to 10. This is equal to negative 9. 10 plus negative 9 equals 1. That works. 5 times negative 1 plus 6 times negative 3 should equal negative 23. This is equal to negative 5. This is equal to negative 18. Negative 5 minus 18 equals negative 23. So it does work for both. I know that I didn't make any mistakes. So number 1 and number 2 were kind of simple problems because you only needed to take one equation and multiply it by a number, and then you were able to solve from there. For number 3, it actually is a little bit more difficult because if I wanted to choose, we can either eliminate x or we can eliminate y. So if I look at number 3, here are the x numbers, 4x and 5x. Here are the y numbers, 3y and 2y. In the previous problems, I was able to turn one of the variables into the other by like multiplying it by 2 or by multiplying it by 3 or multiplying it by negative 2. And in this case, I cannot do that because I cannot get from 4 to 5 by multiplying 4 times like a whole number. So that won't work. Same thing with this one. I can't turn 2 into 3 because I can't multiply 2 times a whole number and get it equal to 3. So this is going to be a situation where the problem is actually more difficult because we have to take both of the equations and multiply them by different numbers. So we need to first figure out what to eliminate. There's no right or wrong answer. What would you rather eliminate, x or y? Okay, we're going to eliminate y. So that means we need to focus on the y numbers. The y numbers are 3y and 2y. What you're trying to do is find the least common multiple that is a multiple of 3 and 2. Sometimes, like the multiples of those numbers, you can always multiply them together and get one of the multiples, but you always want to use the smallest so that you're not making the numbers too large. The smallest multiple that's a multiple of both would be 6, because the multiples of 3 are 3, 6, 9, 12. The multiples of 2 are 2, 4, 6. 6 is the least common multiple, so the first thing you have to do is find the LCM of 3y and 2y, and that's going to be equal to 6y. So what we need to do is take the first equation and multiply it by what? 3 times what is 6?
2.
Yes, I'm going to have to multiply by 2. And I have to take the second equation and multiply it by what?
3.
Yep. So I have to take the first equation and multiply it by 2, and the second equation and multiply it by 3. I'm doing that because in order for things to eliminate, the y's need to be the same number or opposites. It's okay for them to be the same. We'll just subtract them once we get there. So what I'm going to do is take 4x plus 3y equals 21. I need to multiply this all by 2. And it's very important that when you do that, every single number gets multiplied by 2. So I know I wrote that kind of close to this. So step 1 was find LCM. And we're multiplying this all by 2. So 2 times 4x is 8x. 2 times 3y is 6y. 2 times 21 is 42. So now my new equation for the first one is going to be 8x plus 6y equals 42. And then I need to take the second equation, the 5x plus 2y equals 21, and I'm multiplying that by 3. And I'm doing that because I want to try and get it to say 6y. So when I multiply this by 3, I'll get 15x plus 6y equals 63. Okay, everyone with me? I took the first equation, multiplied it by 2, the second equation, multiplied it by 3. Now I have these two new equations, 8x plus 6y equals 42, and 15x plus 6y equals 63. To eliminate y, since these y's are exactly the same, 6y and 6y, I will have to subtract the two equations to solve. So at this point, what I want you guys to do is go ahead and try this. Take a couple of seconds, try and eliminate the y's by subtracting. Make sure you're doing the top number minus the bottom number. All right, so the first part, 8x minus 15x, you should get negative 7x, equals 42 minus 63 is negative 21. So we get negative 7x equals negative 21. We'll divide both sides by negative 7, and what will we get for x? 3. Now that we have one of the solutions, it's time to find the other solution. So we take one of the equations from the very beginning. So one of these here, they both look the same to me. No negatives. One doesn't look easier than the other. I'm just going to take the first one. 4x plus 3y equals 21. And I'm going to replace in what we just found for x, which is 3. And I'll solve. 4 times 3 is 12. So I'll subtract both sides by 12. 21 minus 12 is 9. So I get here that 3y equals 9. I'll divide both sides by 3 and get y equals 3. So both of these answers for x and y are actually both equal to 3. The final answer would be 3, 3 in ordered pair form. And each problem takes a long time, as you can see. Number 3 was not set up for elimination. We had to first figure out what we would like to eliminate. In order to do that, we needed to take both equations and we had to multiply them both by a specific number so that we could eliminate that variable that we wanted to. Then, once you do that, you follow the process, either add straight down or subtract straight down. You'll be able to solve for one, and then you can take that and solve for the other. On the next page, there are 2 practice problems that I would like you guys to get some practice on. And for both of these problems, you cannot just take one equation and turn it into the other one. Like looking at number 1. If you're choosing to eliminate x, Oh, actually, this one will work. Eliminating x is easier for number 1 since you can take 2x and turn it into 6x by multiplying everything by 3. However, if you chose to eliminate y, you can't take 3y and turn it into 5y, so you would have to take both equations and multiply them by a different number. And then number 2, this one, you can't get from 6x to 9x, so you would have to maybe look at the y. You can't get from 2y to 13y, so you'd have to take both of these equations and multiply them by numbers. So I want you to try to find the fastest method, the fastest way to get to your answer, but it does come with practice. But your first choice will be to eliminate x or y, and then multiply by a number to do that. I'm going to give you guys like 6 minutes. We'll go over the answers before the end of class. right, so we have enough time to go over these answers. I'm going to go through the solution with you. So for number 1, the easier variable to eliminate for number 1 is definitely what? X. And that's because I can take the second equation and turn it into a 6x by multiplying everything by 3. So here's what the second equation will look like then. 6x plus 9y equals 15. I then take the original equation at the top, 6x plus 5y equals 19, and rewrite it. And I can take these two equations and subtract them in order to cancel out the x's. So 6x minus 6x cancels out. 5y minus 9y is negative 4y equals 19 minus 15 is 4. To get rid of that negative 4 in front of y, I would divide both sides by negative 4, and I get y equals negative 1. I have half of my solution. Now I pick one of the original equations. I'll just use the first one, 6x plus 5y equals 19. I replace in a negative 1 for y, and then I will solve. 5 times negative 1 is negative 5. So I will add 5 to both sides to solve for x. 19 plus 5 is 24, so I get 6x equals 24. I'll divide both sides by 6. I'm going to get x is equal to 4. So overall, my answer would be x will be equal to 4, and y will be equal to negative 1. So 4 negative 1 is your final answer for this one. For number 2, there is no easy way to just eliminate the x's or y's, because if you look at the x's, we have 9 and we have 6, and we have 2 and 13 for the y. I can't add them straight down and eliminate anything. I can't subtract straight down and eliminate anything. I can't take one of the numbers or one of the equations and multiply by a number to eliminate the other one. So for this, you have to choose whether to eliminate x or y. I think that I'm going to eliminate x because the numbers are a little bit easier than 2 and 13. So what I'm going to do is eliminate x, which means I'm looking at 9x and 6x and looking for the least common multiple. You could always multiply 9 and 6, get 54, and you could turn everything into that, but I actually think that you would want to use a smaller number as possible. So the smallest number, the least common multiple of 9 and 16 is 18, which means you want to try and turn the 9x into an 18x and a 2y and 6x into 18x. That means for the first one, in order to take this first one, 9x, and turn it into 18x, I would multiply everything by 2. For the second one, 6x plus 13y equals negative 9. In order to take the 6x and turn it into an 18x, I'd have to multiply everything by 3. So what these will turn into when I do that is 18x plus 4y equals 78. And on the bottom, I have 18x plus 39y equals negative 27. Now that I have that, I can use elimination by subtracting. I will subtract both sides like this. 18x minus 18x cancels out. 4y minus 39y is negative 35y. And 78, be very careful with this one, 78 minus negative 27. So 78 minus negative 27 is really 78 plus 27, which is 105. To solve both of these things, I will divide by negative 35. And 105 divided by negative 35 is negative 3. So we get that the answer is going to be negative 3 for y. Take one of the original equations and plug in negative 3 for y and solve. And you'll get that x is equal to 5. So all altogether, the solution to this one is 5, negative 3.